Okay, today we're going to try this again. I just tried it and it didn't work, so we're going to try it again. Today we're going to talk about the laws of logarithms. We're going to use this particular property here. If log base b of m, there should be an equal sign here, equals log base b of n, then m equals n. All that means is if these are equal, the log and the base, then it follows that what's behind them here must also be equal. So by doing that, let's look at this first example. And I'm going to pull this up a little bit on the with the mouse. I'm going to pull this up a little higher so I can get two examples on the screen. We notice that both are log base 7, so that part's the same, so it must mean that this 3x plus 5 is equal to 8x minus 12. And once you know that, you've taken out the logarithms, you've made it less difficult. You can just solve it like you've always been solving equations. So subtract your 3x, add 12, okay, and 17 is equal to 5x. So dividing by 5, x is equal to 17/5. Okay. You need to put these numbers back. The thing you need to remember about logarithms, one thing is, you can't take the log of a negative number. So put these x's, when you get them, back in your original equations and make sure you don't end up with a negative number. This one doesn't. The math is a little more difficult, so I'm just going to let that one go, and you have to take my word for it. But we'll check this next one. If you notice, if you remember from 2:1, 3 log base 2 of x means that 3 can come back on that x as an exponent. So we need to make these just as simple as we can. So we're going to rewrite this as log base 2 of x cubed is equal to log base 2 of 27. Now the log base 2 part is the same, so that must mean that x cubed is equal to 27. When you need to solve a problem with an exponent like this, remember, you can raise it to the reciprocal power. The reciprocal of 3 is 1/3. So that's going to give me x to the first is equal to 27 to the 1/3 power. 1/3 power means you're taking the cube root of 27, and the cube root of 27 is 3. So my answer is x equals 3. Then you can check, if I put a 3 here, I would not be trying to take the log of a negative number, and 3 cubed is 27, so that checks out, and you can tell that you have the right answer. So we'll move on to a couple more examples. Okay. In this one, you're going to need to combine these into one logarithm. When you add them, that means you multiply when you combine them into one. So, because it follows, if you remember, exponent rules. Log base 2 of x is equal to the log base 2. This 2 comes up as an exponent, so it's 3 squared times 5. So log base 2 of x is equal to log base 2 of 9 times 5, or 45. Both are log base 2's, so there's really no more work to be done. X is equal to 45. So that was a fairly straightforward problem, but you had to remember the property that said when you add these logarithms, you can combine them as to one as a multiplication. Going on to the next examples. again, we're missing a few signs here. They didn't come in when I saved it as a PDF. This should be a minus and this should be an equals. Log base 4 of 48 minus. Minus means we're going to combine them as a division problem. So when we combine them, we have log base 8 of 48 over x is equal to log base 8 of 4. So 48 over x equals 4. Multiply through on both sides by x, and you'll have 48 is equal to 4x. Dividing by 4, 12 is equal to x. And that should be my final answer. Okay, so let's move on down. I'm going to go ahead and move this cursor down and try to get the last two problems on the screen. Hopefully I can. Looks like it. Let's look at this first one. This should be a plus. It's hard to see, but that should be a plus. This should be a minus, and there should be an equal sign here. Plus we multiply, so this combines as log base 7 of x times x divided by 3, and that equals log base 7 of 12. So we have x squared over 3. Log base 7 is the same. So x squared over 3 is equal to 12. Multiply by 3 on both sides. So you have x squared is equal to 36. Square root both sides, and since this 2 is even, x is equal to plus or minus 6. But like I was referring to before, if I put a minus 6 right up here, I'd be saying to take the log base 7 of negative 6. And you can't take the log of a negative 6. So your two solutions are plus 6 and minus 6. I can't use that one because you can't take the log of a negative number. Okay, so my answer is that x equals 6. Okay. Now looking here, the very last one, we have division on both sides. We've got some exponents we need to pull up to the top. So we have log base 2 when we combine them as 1 of 2x minus 1 over x plus 5 equals log base 2 of 36 to the 1/2 power over 2 squared. Now 36 to the 1/2 power, so the square root of 36, that's 6 over 4, and that's going to be 3/2. Alright, so I'm going to have to move this up because I don't have enough room to work. So hopefully you have written this on your notes. I'll rewrite it after I move it up a little bit. What we end up with then is the log base 2 of 2x minus 1 over x plus 5 is equal to 3/2. Log base 2 of 3/2. And since the log base 2 is the same, what we can say is that 2x minus 1 over x plus 5 is equal to 3 over 2. Now if I multiply through by the least common denominator, which is, we end up here with our x plus 5's canceling out, and we're left with 2 times 2x minus 1. Here our 2's will add out, and you're left with 3 times x plus 5. By doing that, we really perform the same thing as if we had cross-multiplied, and that's what you learn, but that's why cross-multiplication works. You're basically multiplying through by your least common denominator, or least common multiple for the denominator. Alright, so 4x minus 2, doesn't look like a 2, is equal to 3x plus 15. subtract 3x, add 2 to both sides. Okay, just typical solving equation. X then is equal to 17. If you substitute 17 back up here, you end up with no negative numbers, so it's a good solution. So x is equal to 17. And we're done.